Perfect. Again, welcome to the meetup. Thanks for joining. Thanks for taking the time out on Wednesday evening. So this is our fortnightly meetup that we are doing every Wednesday. And this series is Let's Talk Data. So uh, again, highlighting to our members that we have a YouTube channel, and the link to the YouTube channel is in the description for the meetup. All our presentations have been recorded and it's been posted there. We've been getting good views and the views are increasing. So we want more folks to watch. If you've missed out, definitely go to this YouTube channel and watch. All right. So a couple of updates that I wanted to inform the members about. So far, we've been running one series, which is called Let's Talk Data. We are focusing heavily on tech, products, and solutions. We're going to continue doing that. So that series is going to be continued. But we're going to introduce a new series called Industry Talks. So where we're going to focus more on data or analytics-driven use cases or case studies. And we're going to bring speakers from industry verticals like FSI or retail, public sector, health and life sciences, speakers from across the industries in the data space to just share what they've done in their industry to actually solve problems using technology or any idea that they have implemented. They'll be sharing in the industry talk. So that's a new series that will be starting soon. And we also welcome our members to come forward and present if you have a good topic that you think is worth sharing. So, always feel free to reach out to us and we'll be happy to organize one. And the next update is the meetup format is going to be, 5 minutes of introduction, at least the virtual ones for now, right? So it's going to be 5 minutes of introduction or meetup updates if you have any, and then 30 minutes of presentation from this presenter. And we'll have 10 minutes of Q&A. And finally, we will do 15 minutes of networking. We'll be creating, breakout rooms, and we will give you the opportunity to network within the member group here. So that's going to be the format for the virtual ones, at least. Once we ramp up, the group, because we've been doing it only for the 3 months now, last 3 months. Once we get a good amount of people turning up for the events, we'll also plan to organize in-person meetup as well. And finally, we have introduced a new program called Anchors. So it's not just restricted to this list, right? So we've been, we actually want to have anchors from different vendors, be it AWS, Azure, Google, Oracle, IBM, Tableau, Talent, Click, any of these providers. I'm just looking for anchors. So the goal of here is to have anchors in place from these providers who can bring recurring topics, or who can bring speakers internally from their org to actually present to this group, right? So we have had a couple of anchors now, so one from AWS and one from Google, and I'm in talks with Azure and Oracle as well to have anchors. And this is going to be growing. So we will have anchors in multiple vendors, and they're going to share real good topics from their field or their product, which is going to help our community real big. All right, so now it's time to introduce the man of the hour. So Michael Blake. So Michael Blake is our presenter for today. He is located in Brisbane, and he is an innovation data and AI specialist from Google Cloud. So Michael is an ex-AWS person as well, and he has been vice president and CTO of BBC Studios in UK. He has real rich experience in the data and AI space, and he also has been in the product management space as well. And in terms of industry experience, Michael has worked across industries, be it energy, utilities, mining and resources, retail, gaming, FSI, public sector, you name it. Michael has the experience. So it is really our honor to have Michael present to this meetup group. And Michael, really thank you for doing this. And I'd probably hand it over to you now, and so you can share your screen.
Thank you for that introduction, Deepak. Make me sound much better than I probably am. I just want to check one thing before I start. you want me to turn off my video as well?
Bracken, what do you think?
Oh, sorry about that. No, that should be fine.
Yeah, I'll just leave it as is. Great. Yeah. Okay, so assuming you can all see the screen, thank you for the introduction. Very kind introduction, and thanks to Deepak, Bracken, and Jason for asking me along tonight. So as Deepak's already said, this is Let's Talk Data with Google Cloud. What we're going to cover tonight are some very quick introductions, nowhere near as good as the ones that have already been done. A super quick level set to make sure we're all on the same page. And then we're going to step through building a data pipeline on Google Cloud Platform, looking at various different options. It's going to be kind of 101 level, not going too deep. I hope that's the right level. And then we'll wrap it up at the end and hopefully have some dialogue. So as Deepak said, I'm a customer engineer. Well, he didn't say it, but I am a customer engineer in the Google Cloud team, and it's my job to help Google Cloud customers solve problems usually using data and AI and innovation workshops, that type of thing. So unlike me, Google probably doesn't need much of an introduction, but I'll just spend 30 seconds on this because it actually probably is meaningful to understanding where Google Cloud fits. So the side of Google that everyone sees, like Maps, Chrome, Android, all of that sits under Google, under the Alphabet parent company. And then on the other side are companies that you're probably less familiar with, things like Wing, which is a drone business, Waymo, self-driving cars. I bet people in this group probably know about DeepMind, which is Google's AI lab. They're kind of known as other bets, and Google Cloud sits in the middle. And it does that because all of these things are hosted on Google Cloud. So all of these things, products that have got 9 apps with over 1 billion active users each in global scale, we get the benefit of that awesome R&D, which is pretty cool. So what does Google Cloud do? Everything, as this slide shows here. Now, whether it's infrastructure, networking, you name it, but of course, we're not going to talk about that today. We're going to zero in on data analytics and a little bit of AI. So now, please indulge me in this. I know this is an advanced analytics meetup, and for most of you, this will probably make perfect sense. So this is going to be a very quick level set, but just bear with me because it does help set the scene for Google's general reference pattern and why we have the reference pattern. Okay, so traditional data analytics, wonderful that it was. Worked in a very, very simple way. You had transactional systems like ERPs holding, let's say, sales data, be batching this historical data into a big enterprise data warehouse, usually on some kind of weekly or monthly schedule. That data warehouse did everything. It processed, it stored, it analyzed, and then it spat out some insights at the end, usually answering some type of question like, what were last month's sales? And also, how much inventory might we have? And that was wonderful, but the world has changed. So super quickly, what has changed? So that old paradigm was built to handle very structured data on a batch and really not that big a scale. But now we've got real-time event data coming from wearables, IoT, we've got video, audio, documents, connected machines, geospatial data, all of this that these old systems were not really designed to do. It's not their fault, they just weren't designed for it. And then also our business stakeholders have got new problems they want to solve. They want to predict what might happen tomorrow rather than look back on what's already happened. And the upshot is the traditional paradigm doesn't work. So of course, new data and new opportunities, we need a new approach. So this architecture, I'm sure plenty of you have seen this before. Some people refer to it as the Lambda architecture, the two-speed batch and real-time architecture. But basically, it breaks down to this. So you need the ability to collect data in both batch and real-time, to process that data in both batch and real-time, to have highly scalable storage. That's something that the old paradigm couldn't cope with a storage decoupled from the compute, meaning it's not bound on a particular disk. And then, of course, we've got way more persona types or different interested parties within our organizations now who want to do things with the data. So the old data warehouse used to be the domain of the BI warrior and maybe the data analyst. But now we've got business users, developers, data engineers, data scientists who all want to get at that data. So we need the right tool for the right type of person at the right skill level so they can access the data. So they can start solving some of these cool problems you see on the right here. Right, so that's the level set. Thanks for bearing with me there. Let's now look through building a data pipeline with GCP. So we use a scenario of a company, very imaginative name I came up with there, Retail Corp. They're a large retailer. They've got lots of physical stores, but they're lagging behind their competitors. They've got a big traditional enterprise data warehouse on their premises, not in the cloud, and it's got all their sales and customer data. And a good thing happened to them. Their founder's granddaughter retired, and his granddaughter's taken over as CEO, and she's decided to make changes. They launched an e-commerce website, and they want to solve new business problems and catch up with their competitors. And they looked to us as their data analytics and AI team to help solve those problems. So let's look at what data they have. They have two groupings of sources. Now, look, this is a pretty happy path scenario here, but we just want to make sure we have enough time to do it justice. So we've kind of grouped them into two main areas. So there's the enterprise data warehouse that's got sales and customer data hosted on premises. And then they've got this newfangled marketing data from things like Google Ads, Display and Video 360, YouTube advertising. That's all now connected to and coming from this e-commerce website that they've launched. And the challenge they've given us as their team is to get this data into some form of data store in the cloud. And some of the high-level requirements they've given us, they've said, well, look, this data goes back about 8 years. It's around 1 terabyte in size, we think. And with all these new sources of data coming in, it's probably going to expand by about 1 to 3 terabytes a year. So we need some scale. And they want to run daily reports instead of their old monthly reports, so the freshness of the data can be no more than a day. They want these reports to be written by data analysts, likely using SQL, and they want this to be as close to no ops, i.e. low or no code as possible, cost effective and quick to deploy. So we'll keep that in mind as we step through. Right, so first things first, where should we store this data? Let's look at the 4 main options. Now, there are many more options, but again, in the interest of time, we're going to keep this simple. So the first one is Cloud SQL. So Cloud SQL is a relational database as a service. You can host MySQL, Postgres, SQL Server, and these are awesome database engines, and it's a great service. But it's not really designed for analytic use cases. The compute and storage of a database, transactional database engine is bound, right? So there are scaling limits and there are limits to how much data can be processed by queries on that. So we'll park Cloud SQL. It's not for us. Bigtable. So Bigtable sounds cool. Okay, right. We need to store large volumes of data. Bigtable can do that. It's a global scale NoSQL database. It can scale to billions of rows, but its job really is more for collecting telemetry like time series data from sensors or those really industrial use cases. Now we could probably use it in this scenario, but it's not really fit for purpose for us. So we're going to park it. Now the third one is Google Cloud Storage. That's object storage. So some of you might know what that is on Google Cloud. Some of you might be familiar with S3 or Azure Blob Storage. It's basically a place that you can store objects or blobs and scale to almost unlimited amounts of data you can store there. Highly durable, really cheap. This could be a go. We could, in theory, store all of this data in cloud storage. We could apply some kind of query engine over the top, and we could start analyzing. But there's some building there, right? We'd need to bring a tool to query the data, and we'd need to make sure we had it partitioned properly and all that, and that smells of a bit of complexity. So for bearing in mind our use case of moving fast and as no ops as possible, we'll park that one, and that leaves BigQuery as the last option. Now I'm going to dive into BigQuery in a bit more detail because it really is at the heart of everything on Google Cloud. You'll see it everywhere because it's more than one thing. It does many things. So it can scale in terms of storage to literally exabytes of data. You can run a query on your data in Bigquery that can scale up to petabytes. There's no upfront provisioning. There's you don't need to sign up for a tier or anything like that. It's just you put your data in and you use it. No vacuuming or anything like that required. It's quite different. And all that data is encrypted. It's sharded across each zone in a Google region, so it's highly durable. But there's a couple of things about Bigquery that I'd like to draw your attention to that make it probably a good candidate for us to store this data. So the first one is its architecture. So earlier on, I said that we need storage we need an analytic engine that has storage and compute decoupled, so they can scale independently. And that's what Bigquery does. On the left-hand side here, you see this 11 nines of durability storage. That's basically object storage, right? So that's why it can scale so high. And on the right-hand side, this think of it as the query engine, right? Known as Dremel, invented within Google over a decade ago to analyze this ludicrous scale of data that they had. Productized so that now you have this query engine that can scale independently of the data that's stored in it. And it's also really cheap, which is pretty cool. So that's how it works. That's why it's able to scale in the way that it does. The second cool thing about it, which could be useful for us, probably not with our current use case, but it's this streaming capability. So I've seen data warehouses, sure some of you have as well, that you can stream data into, but then you actually can't access that data. It's micro batched and you might need to wait 10, 20 minutes before you can analyze it. Well, you can stream data into this Bigquery streaming buffer and immediately query it. And I mean immediately. And there's an example we've got of a vehicle telematics customer in the US that's got data being emitted from a sensor in a vehicle, streamed in through services I haven't mentioned yet, so I'm not going to mention them, processed and into Bigquery and on a real-time dashboard in under 3 seconds. So that's the type of near real-time we're talking about. So that's pretty cool. Bigquery AML, of course, ML is everywhere today, and everything has got ML with it. But this is actually real. You can, with an SQL statement, you can define a machine learning model against data you've got stored in Bigquery, and then perform predictions against other data in Bigquery, again, just using a SQL statement. Pretty cool. But the best, and I think probably the most interesting for this group, is this capability, is this data lake interoperability. So a historic weakness of a data warehouse, right? You've got all of this data in there, all your data, but then you want to start running Spark jobs against it, Hadoop, machine learning modeling, but they can't get the data out through these ODBC and JDBC connections in the volumes they need. So the data usually has to be unloaded onto object storage or a disk, then processed and then discarded or whatever. But it's an overhead and it's a bit of a pain. But with this Bigquery storage API, you can actually have a second way into the data in Bigquery. It's like accessing the raw data underneath. So then all of a sudden, this cloud data warehouse starts looking a little bit more like the data lake, which is pretty cool. So way overkill for this use case. Let's just say we're sold and we've decided, yeah, Bigquery, that's what we're going to use. And I've got Bigquery storage and Bigquery analysis as two logically separated icons here, but it's all just Bigquery. But I just wanted to point out that there's kind of two things happening here. So now we know where we're going to put our data. Great, that's a great start for us. Now we need to figure out how we're going to get it into the platform. Of course, it's always one of the hardest problems in data analytics and AI is actually getting our hands on the data. So a few options, of course. So let's look at the streaming options first for the sort of ingesting data in near real time into the platform. So there's Kafka, which is a first-class citizen within Google Cloud. There are native connectors for Kafka throughout all of these services you're going to see here. But there isn't a Google managed service for it, and it's a bit more heavyweight. PubSub is the alternative. Now, as it sounds like, it is a pub sub publisher subscriber message queue. designed to decouple applications from each other. Now you're thinking, well, how can that do streaming? Well, it actually operates in two modes. So one is regular pub/sub mode, and the other is push mode, where it acts as this ludicrously scalable data streaming capability. It's cheap, it's easy to use, and I think if we had a streaming use case in this requirement, we'd probably use pub/sub because it's easy to get up and running. But we don't, right? Our requirement, as you may remember, was data freshness of around about a day. So daily batch ingest is fine for us. So we'll ditch these two streaming examples. And IoT Core, also not appropriate for us. IoT Core has a protocol bridge that allows you to easily stream in huge amounts of data from like industrial things and wearables out there beyond the cloud. Again, not for our use case, so we'll ditch that. Then we have this transfer service. There's actually many different transfer services. There's transfer services that can take data from the Google marketing stack of products that we're using in this use case and deliver them to cloud storage or to Bigquery. Now, we're going to use that in this solution, definitely, but there are other managed no-code transfer options provided here to bring data from Teradata, Redshift, S3, Azure Blob Storage, all with no code, which is pretty cool. And also other ones that can collect data from other clouds, non-cloud, like on-premises locations. So one way or another, we are going to be able to get that data in using one of these transfer services. Now, I've put Marketplace down here just to point out that we could have gone onto the Google Cloud Marketplace and chosen a third-party data management or transformation service, but for the purposes of this, we'll leave that to one side. So we've settled on the transfer service. We've also found out conveniently that our customer already has a data integration service in their network on-prem, and that can deliver a daily batch to a location that the transfer service can read from and bring it into Google Cloud. So awesome. So we've now got a no-code data ingest capability that will land these data files from Google Cloud Google marketing data like Google Ads, all that kind of stuff, and also from the data warehouse. And that will build up on a daily basis in cloud storage. So awesome. And we still haven't had to really write any code, which is even better. Right. So now we need to process this data. So we can't analyze it in place. It needs to be transformed to meet our needs. So again, let's look at a couple of the options we've got here. So the first one is Data Proc. So Data Proc is the place where you can run open source tools like Spark, Hadoop, Presto, you name it, almost anything. And basically what you do is you spin up a cluster, you tell Data Proc what to deploy on it, it deploys it, and then you use that cluster to do your data crunching job. And huge, vast, complex problems can be solved with Data Proc. But if we think back to our scenario here, we've got a requirement to move fast. We've probably got an unskilled team, and in the wrong hands, this kind of tool, it's not going to cut it. So let's leave Data Proc for now. And the same goes for a custom app. You think, well, maybe we could write some kind of cloud function or our own homemade app, which could just process this data, join it, and stick it in BigQuery. Yeah, we could, but you know what? There's a lot of moving parts there, and it's not going to be quick, and it's going to have bugs, and we're going to have to manage it. So no, the marketplace again. So you can use something like DBT, Fivetran, Matillion, all excellent tools, but for the purposes of this, we're going to focus on the Google tools. Let's look at Dataflow. So Dataflow is an interesting one. Dataflow is managed Apache Beam, and it can process data from streams and both from batch sources and join them together and write them to another location. So I'm going to whiz through this really quickly. I just want to show you this graphic really. So Dataflow can merge both batch and streaming data sources together, and multiple of those too, and you can do a lot with that data, right? You've got a set of pre-built templates for your simple use cases. You can use the Java or Python API. You can also use SQL to in that blue box there to actually do that streaming. To do that to define that transformation job, and then that data is then output to one of these sinks. So think of it as sources and sinks. So it can read, Dataflow can read data from BigQuery, Cloud Storage, PubSub, Bigtable, Firestore. We haven't talked about that, but we're not going to tonight. But it can read from many of these places and do its job and write that data out back to those places. So for our requirement here of getting our customer sales and marketing data and processing it and writing it to the place we want, this could be the thing to do. I mean, it can definitely do the job. But on the downside, we might need to write some code. And our requirement says we need to move fast. And let's park this one. I think we could use Dataflow, but is there an easier option? Of course, we always need to look for the easier option, and thankfully there is one. So data prep is a visual browser-based tool that's part of Google Cloud Platform that allows you to load data from cloud storage or from BigQuery and to visually manipulate that data. So you can see a little bit on the bottom here, this screenshot. So you can perform some quite complex transformations. You can write what they call recipes to identify missing data. You can normalize your data. You can split fields. You can merge data sets. Yeah, you can see some of that on this next one. Really powerful. So you can, all of a sudden, you've got a no-code way of doing some pretty hardcore data engineering. But even cooler, if we go with this approach, under the hood, what happens when you save this recipe, as they call it, it generates a Dataflow job. So we've got the benefit of having this sort of browser-based easy tool, but then the execution of it is in a highly managed, repeatable, almost limitless scale processing engine in Dataflow. So we've picked data prep for that, the data wrangling, and data flow is that sort of slightly opaque engine that's doing the job under the scenes. So that's, we've gone a long way here. So we've written no code, but we've got regular data coming in from our sources. We've got repeatable transformations taking place on that data, and it's now being delivered into BigQuery. So we're almost there, but we need to visualize that data. So let's just quickly look through these options as well. So the first one, Cloud AI, we're not going to go there today because we don't have enough time, unfortunately. But what I will say is think back to that streaming API I talked to you about, sorry, the storage API for BigQuery that allows you to access that data in bulk underneath. All of these AI services, now there's one icon there, but there's a lot behind it. Whether it's a Jupyter Notebook, a managed machine learning modeling, training service, all of that can just be pointed at that BigQuery data. So the pattern here is data stays in one place, you bring the tool to the data. And the goal is to just make life easy for people and reduce the need to be duplicating and copying things. But as I said, not today. We're not going to talk about AI. So we've really got three options here. We've got third-party visualization tools, Data Studio, and Looker. So on the third-party visualization tools, that logo, of course, is Tableau. You could bring really whatever visualization tool you wanted to visualize data in BigQuery. It's got JDBC and ODBC connectors. You could even use Power BI, and some people do that. But again, we're going to focus on the more Google options for this because that's the purpose of the talk. So that really the two options we're going to focus on are Data Studio and Looker. Data Studio is free. It's awesome. You can build visualizations. You can connect it securely to BigQuery, to a data set in BigQuery. You can build visualizations. You can have them access control to people within your organization. You can embed them. in other web pages, really good. But on the flip side, it's got no SLA. There's no semantic layer, but could be useful for us. The more heavyweight option is Looker. Now, Looker is really cool. So it's comprised of this sort of governed semantic layer they call LookML. Conveniently misnamed, I think. So ML's got nothing to do with machine learning. That stands for the modeling layer, semantic modeling layer. And this, you can treat the modeling layer as most customers keep it in source control. So it's governed from that perspective. And the best thing about this is the set of automagic APIs that are generated around it. So let's say you've got the semantic model, the semantic layer over all of your data sets. Here we've only got one data set in Bigquery. Let's say we've got 10 data sets in Bigquery. We've got data in AWS. We've got data in Azure. We've got data on-prem. And that semantic layer could sit across all of them. And we could have a set of automatically generated APIs that would allow you to build your own data apps around that. Now that's quite powerful, and that's actually one of the coolest things here. But our requirement, coming back to our requirement, is to have something up and running quickly. So for now, what we'll do is we will go for Data Studio in the short term, and then we'll start looking at Looker, assuming that our management are going to be happy with what we've done and want this to be more productionized and governed in the future. So we're almost there, but of course, if we can't orchestrate this, then none of it's going to work. And what I mean here is, some people talk about choreography, some talk about orchestration. Choreographed one might be, there could be a schedule, like a cron job almost, that runs on this transfer service that lands the data in cloud storage. That could fire an event, and that event could trigger something to tell data prep to start its job, and then the data would be loaded into Bigquery. But if something goes wrong, data pipelines do break, right? It's a fact of life. In that choreographed scenario, what do? We just know that our data hasn't landed today and our reports are failing. Probably not the best thing to do. So we're pretty better to orchestrate that. And the best option within Google Cloud is to use what we call Cloud Composer, which is Apache Airflow. And if any of you have used that, it's pretty powerful tool, and allows you to really just wrap a set of programmatic instructions around every step in this process. And then you can have it go into your logs and monitoring. You could have failed steps repeating. You could even build this into some kind of data quality check, where if your data, you're expecting 1 million rows a day and you only get 2 tomorrow, maybe send some kind of alert. That you can start to build that kind of stuff in here. But for our simple requirement, we're simply going to orchestrate this thing. And really that's it. So that's our challenge that we had at the beginning, was to get the data into a cloud data store, tick. To be able to cope with a terabyte of data and scale by 2 or 3 terabytes a year, no problem. Have data with around about a day's freshness, great, absolutely achievable with this solution. The data will be refreshed every day. Those data analysts can write their reports using SQL, and this solution is as close to no ops as possible. The only thing that isn't is the orchestration. So we'd need to write a little Python DAG, as it's known, but it's pretty basic to define these steps. So the only bit of code we're writing there is around the orchestration. But that's it. So that's how you would build a simple batch pipeline on GCP. Now, there's so many more ways you could do this. You could have just tried to load it directly into Bigquery and take an ELT type approach and transform the data in situ. But if we'd done that, we wouldn't have been able to tell you about these other cool things. So a cleaner view of that platform looks a little bit more like this, right? Where you've got these data ingest, processing, storage capabilities. The ones the key patterns that we really see for streaming data, it's PubSub to Dataflow to Bigquery. All of them can cope with streaming data, and you can have real-time dashboards feeding off that and real-time use cases. Sorry, near real-time. And then the common pattern for batch is for that data to land in Google Cloud Storage, from whatever ingest tools we've picked, and then again to use data flow to process that data, and then put it into Bigquery. And this view, now we're going to share these slides, so don't worry, you can't take this in all at once because nobody could. This might be more interesting to peruse at your leisure. So it's a sort of persona-based view of all those different services. So if you're a developer, you know, what might you use for data processing? If you're a data scientist, how might you do, you know, what tool would you use if you want to do Spark, you know, Spark job, and so on and so on. But we'll stop there. I'm probably over time. Thank you very much.
Thanks, Michael. That was really great. I mean, that summary from data acquisition to how it's being used in the end, what happens in between, that was a really clean and an easy flow for us to, you know, I mean, for everyone to actually understand. Thanks for that.
Thank you very much. Yeah, I wasn't sure that I'd hit the right level. I know there would be things in there that some people here would be like, "Yep, I learned that a while ago." But I thought the level set might help at least explain why you would kind of split things up like that.
I think it makes a lot of sense, and it's making it so much easier to follow. I am just going to kick off a question for you so that the rest of the group can also have some questions to ask you. In your experience, typically, how long does it take to set up that whole entire process, considering that you already know what's the solution that you need, the problem you need to solve, and also perhaps to some extent, given that you're familiar with those components, so you sort of like know what to choose already. But how much do you think people can get up and running?
Really quickly, honestly, you know what, the technology isn't the blocker, it's people and process. Always the case, right? So you could have a fairly enterprise level version of that running in a short space, in a few days, realistically. And the things I missed out, which are actually really important, there's a capability called DLP, or data loss prevention, which, you know, we missed that whole compliance and, you know, that compliance side of things. But in the real world, the thing that slows everything down is the customer wants to make sure the data is classified correctly, that the wrong people aren't going to get their hands on it, all that kind of stuff. So that's always the thing that slows it down. Now I didn't go there today because we don't have time, but you can, there's some pretty nifty row and column level permissions you can put on data in Bigquery that can sidestep some of that stuff. You can have the data masked as it flows in. You can have it masked in a batch way as well. So if you've misclassified anything and it's snuck through, that's a long-winded way of answering your question. The technology, you can stand this up pretty quickly, honestly, but it's getting the security teams and the compliance teams across the line. That's always the thing that takes time.
Indeed, I think that being said, the compliance and the security, I suppose that seems to be one of the biggest hurdle for the large enterprise to move away from their existing process and existing platform to be using this. How has that been much of the success, or what would be, apart from the compliance and the security?
Well, I've found through experience, both here and when I was at AWS and when I was at the BBC before that, start all conversations with the security team. Be their best friend, buy them lunch, sit next to them on the bus, whatever it takes, and just start with what are their requirements, what compliance are they bound by, and talk about threats and mitigations. Because so often, I'm sure we've all heard it before, the answer is no. What's the question? But if you start by understanding that and talking their language, okay, you have this threat, great. Well, we've got these wonderful mitigations. What's next? It becomes hard for them to say no. Get them as an early stakeholder. It's not really a data thing, I guess. It's more of how to navigate the security team.
Good stuff. Anyone else have question for Michael? The room is open.
I've probably thrown a question while the members think. So, the data flow working with data prep and the orchestration layer using program. I mean, if I understand this right, so you have cloud data prep, which is the visual tool out of Traffic. So you can visually, orchestrate your data pipeline. And then for your complex jobs, that's when you'll write a data prep job, and then you'll call a data prep job within your data flow pipeline.
Well, that's where it can get a little bit inception-y. I know where you're coming from there. So I missed something out today deliberately, because it would have been confusing. There is something called data fusion. Now it's a visual tool to build the whole pipeline, from ingest to processing, the whole thing. But it's quite new, and you usually need to write your own connector code and that stuff. But data prep just does one very deliberate small job, which is helping you visualize, let's call it raw data or source aligned data, and then allowing you to, the things that we would do in a notebook, or we'd bash through these things in code and some Python. It's the visual version of that. And when you press save at the end of that, it writes the code as a set of instructions, and it uses data flow as an engine in the background to do that. And you can actually orchestrate, not the orchestration of the visual tool, because that would be crazy, but like once you've created that recipe, that can be orchestrated with an Airflow pipeline. And I don't know about you, but I've seen across many companies I've worked with that the gap in the skills is usually in that place. The people who can actually make the magic happen and get the data from here to here and change it. So having a tool that you can clickety click is that's the job it's trying to do.
Perfect. And what's the catalog and governance story here?
So I had a section on that and I pulled it because we wouldn't have had any time, right? But there is a capability imaginatively named data catalog. So it can store both technical and business metadata. So that the technical metadata is the schemas of the data that's come in, lineage tracking. So this data set came from here, was merged or transformed with that. And so you've got that sort of provenance of the data set. Let's think of that as the technical metadata. But you can also apply business metadata that might be useful for your business when you want to search or discover that data. Now, it's by no means gold standard product. It's pretty cool, but let's think of it as like, imagine it's doing their lineage tracking. Great, that's solving a problem. But if you want a real gold standard data catalog, it can hook in with something like Calibra. So it's got a strong integration there. And really that sort of the governance thing, if you think about it up front and you make sure your data is correctly classified, and then the catalog knows what classifications data should be. You can use DLP, that DLP service I mentioned before, to mask or encrypt or redact or remove any data that's been misclassified. I'm not going to bag any competitors, but let's just say previous places I've worked, it wasn't always that easy to achieve that. But these tools actually make it not that hard to solve that problem. And let's be honest, it's quite a hard problem to solve, the governance and lineage, but it goes away to solve it.
I got a question. I got a SaaS, software as a service product, and it pretty much does what it has to do in terms of the functionality. One of the things that I'm looking to add is the OpenAI with the NLP, because that is something that I need from there. If I'm going to add the OpenAI component, where does it sit? I presume it would have been collect, process, store already, and which is the last bit that OpenAI comes into the picture. And just FYI, also the whole entire software is sitting in the Google Firebase server.
Yeah.
Well, so where does the OpenAI?
So that's it. It doesn't fit into those neat swim lanes. Is the short answer. So just to make sure I understand the question. So you want to use, let's say, like the NLP API to, let's say, you pass some text in to get some kind of understanding, or okay. You can just call those APIs from your application. Actually, what you sometimes see is data flow. Think of right back to data flow, that sort of processing pipeline, where the data flow job might, let's say you've got data that's coming in from a stream, let's say a stream of user comments, and it's coming into being read by data flow, and data flow is taking each bit of text and going, okay, this part of the pipeline, pass this text to the NLP API, I get a response. Okay, cool, I know what to do with this. And then they change the message, and then next thing they might be calling another API, calling another ML endpoint, that type of thing. But for your one, where you're calling it from that app, you can just call the API directly. If anyone's had the misfortune of dealing with those Google APIs before, I had in my old life when I was a developer, calling like creating signed requests to the Maps API. Once you've got your head around that, it's easy. But the complexity there is around just around creating that signed request to the API endpoints.
Right, that makes sense. That makes sense.
Michael, sorry.
Go for it, Sarah.
I had a quick question for you. In that architecture diagram, you were showing the use of the transfer service to move data across.
Yes. Yes.
Can you orchestrate that using data prep as well?
Not data prep, but what you can do is, let's say you've got Composer telling data transfer to pick up this data. In fact, it's got its own kind of scheduler inside it, right? So let's say data transfer delivers that data to Google Cloud Storage, and then it could be event-driven, like that choreographed thing I mentioned before, where it triggers the next thing, which could be, the data flow job to process it, or it could be more orchestrated, where that Composer or Airflow job knows at this time every day, I will get this file with today's date timestamped in it in the path, and I will start. If that answers the question. So.
Yeah, it does. Thank you.
Okay. But there's the third party, like partner tools, are some of the coolest things there actually. So it feels a bit selfish only talking about the Google ones today, but things like Fivetran, Stream, which is STRIIM, they're really cool. Like you can do a lot with those. DBT, I suppose that's more of a transformation thing, but the Matillion as well. That's actually something that's cool on this platform, is that it's pretty open. So you can, where you see the Google thing. So we had data proc there for Spark jobs. Well, guess what, Deepak? You could run instead of data proc. You could have some Databricks capabilities there, which would just neatly and seamlessly fit in. So it's an open shop, I guess. That's
okay. That was going to be my next question to Deepak, actually, whether Databricks does run on Google, but because I know it runs on AWS and Azure.
Yeah. Well, we have plans, so you'll have to wait and watch.
Okay. All right. Fair enough.
You'll hear soon.
Yeah. Okay. But it doesn't. My assumption is right, correct? Currently, it doesn't work on Google.
Currently, it's on AWS, Azure, and Alibaba. So Google's going to be real soon.
Okay.
Yeah. Looking forward to that one. Be pretty cool.
Okay. Yeah. One request to Deepak: are you going to be organizing something with Alibaba soon?
Yeah, if you bring me some interest here in the market, I can definitely bring in some folks to talk. Well, cool. Hey, one real quick question, Michael. So, what is we have this collab notebooks, right? So,
yeah.
How does that fit in this architecture?
So, under the AI platform, Now, they've been renamed a couple of times. They were known as Data Lab notebooks. Now they're just AI platform notebooks. So those notebooks, it's a hosted notebook. And when you go into the console, you pick what you want on the notebook, you know, TensorFlow 2.3, or you want just plain Python, or you want this, or you want that. Or you can bring your own. And then it creates an image, a VM in the background, loads up, you get your Jupyter Lab interface. And it's, you can use those notebooks to interactively query the data in Bigquery using that storage API. I've said it about 100 times, storage API. It is really cool though. And I think if you think about how something like Databricks might seamlessly access that data at super low latency and high volumes, I'm telling you now, if when the day comes, they'll use that approach. It's really the same as the notebook. And then from there, you can orchestrate, you can do your modeling, you can trigger a training job with all the hyperparameter tuning, you can do this, you can do that. And then you can save the state. But they finally, we've had it for a little while now, the capability of sharing state across people in the team on a notebook. So it used to be, well, everyone, I think everywhere pretty much, it was like a little siloed notebook. But now that there is a capability of sharing that state across others in your team.
Okay, so as of now, it's at the end state for mostly around your machine learning build, you know. So okay, so notebook-based ETL is not something that's. I missed out something really important. You've just triggered the memory there. So you can interactively talk to data flow through it, notebooks as well. Okay.
And of course, look, if you've got Spark stuff in the background, you can do that. But just out of the box, easy, bang, go. It's all there with data flow and Bigquery.
Perfect. Cool.
Yeah.
Sorry, Chris, any more questions for Michael?
I've got one quick one once the file engine goes away. So basically, with Google, right? I noticed you have two types of notebooks, obviously, sitting there. So one is Jupyter notebooks, and one is lab notebooks or Google Cloud notebooks. Can't remember the exact name. Which one's the managed one, and which one is purely for an internal development use? Do you use, what scenarios would you use them?
Well, so are you referring to the Google Colab things that you can use online for labs and stuff like that?
Yeah.
Yeah. Well, those aren't really part of Google Cloud. It's like that funny line across Google. So within Google Cloud, the AI platform notebooks are something that you would spin up there within your project. So they're isolated, they're secure. It's like an enterprisey thing. And then on the public facing side, where the rest of Google gives these free developer labs, Colab is like an online lab capability, online notebook capability that they provide as part of these, usually free online learning resources. So that's the difference there.
Okay. One last quick question. The free Google Cloud credits, right?
Yes.
Something I have signed up for. I have been burnt badly by them because I've stood up projects, I've stood up environments, left them running, thinking I deleted the underlying resource, thought they were deleted, came back about a few weeks later, I've got a nasty shock with $1,000 bill, which is not good. But I've managed to sort that out, so that's not the issue. But so when you create a resource in Google and you want to delete it, what is the best way to make sure you're not charged that extra amount, basically?
Yeah. So how long ago was that, by the way? That
happened within a year ago.
Okay. So you can set up billing alerts and billing alarms. So if your bill goes over a certain amount, you can be notified. Then that's probably the first safety net. That's what I've got on my personal account, by the way. I've done this before as well when I worked at my former employer. Setting up billing alerts and billing alarms is the first thing. But I try and build everything sort of scripted as infrastructure as code, even if it's wherever possible. So I've got something that I can programmatically tear up and tear down really quickly, and just got into the habit of doing that. But there are more things, right? You can set up budgets, you can set up billing alerts. That's probably the safest way, just to make sure that if you ever do spend over a certain threshold, you know about it and you can shut things down fast. But this whole service catalogs, there's a lot of stuff in that space. But the budgets and the billing alerts are probably the best place to start.
Okay. That's pretty common across clouds, budgets and billing alerts, the first level of defense.
Yeah, none of them used to have it though. The good old days for them are gone now. Now people are being warned.
Yeah, a problem for me was, it was the first time I set up a Google Cloud account, because this was part of, I was trying to do my certification, so I was trying to study for them. So I just created them on the fly and completely forgot about them after that.
There's something else they do as well. They're really risk averse. So there's an algorithm that checks behind the scenes kind of effectively how fraudulent you look. And it doesn't obviously look at you, the individual. You've got a new account, you haven't paid an invoice yet. If you try and spin up a global cloud spanner cluster that's going to cost thousands of dollars a day, you'll get a notification saying, no, please call us. So I think there is another safety net for that kind of thing.
Okay.
And now you know, if you get $1,000 bill, pass it on to him.
Yeah, you never know, right?
I'm not paying it. I'll pass the invoice. I'll pass the invoice to Michael.
Good stuff. I think that is it. Thank you so much, Michael, for this presentation. I thoroughly enjoyed it, and I'm sure the rest of the room do as well. Looks like we only just have 5 people left. So if anyone wants to stick around for the networking session for 5 minutes, let's not worry about going into the breakout rooms. Just stick around here then. How does that sound?
Sounds good. Or we can create one breakout room for each of us.
That would be so hard. Hey, Chris.
Hey, it was pretty interesting. One of the things I was wondering about the reports, that presentation layer is, you know, you've obviously got different groups of people consuming the data in different ways and writing their own reports. And are they isolated from each other through the presentation layer, or?
Yeah, they absolutely can be. So that in BigQuery, all permissions kind of flow from the data set. So a data set can have many tables. You can set permissions at the table level, but it's normally at the data set level. But you can isolate at that level, and but then within the visualization layer itself, of course, you can as well. Now, something like Data Studio, that's the cheap and cheerful free one. You've got limited options, right? It's probably going to be blanket permissions, unsophisticated permissions. But with something like Looker, you can get really clever and have ultra, granular permissions there. And then let's say you're using something like Tableau, you probably have the permissions tied to the data set that it was talking to. I reckon. But yeah, you can go pretty granular with that.
Makes sense, yeah. And the other interesting thing is that in certain, like you might have security zones as well, which I guess once you get into that kind of cloud architecture, you're kind of setting up like virtual networks to control security zones as well. And is your data able to move? Like, sort of
I know. Like, let me play back to think. So I've got it right. So if you think of like from a networking security perspective, you have like different zones to isolate things. But in this world where most of these services are all managed, you can still create the same approach. But some people call it like a data bunker type architecture, where you can isolate the data with different encryption levels based on who you want to see it. So you can go really nuclear with these permissions. You could say, let's say you've got 3 classifications of data. You've got anyone in the company can see it. You've got contains some PII, and then you've got you must die if you see it, only the CEO. Let's say as that data comes in, each data set will be encrypted with an encryption key that's aligned to that classification level.
Yeah.
Then you could have IAM roles, those are your read permissions or read roles, which are again aligned to that classification level. And then so down the road, by the time somebody comes to visualize it, let's say you're in a team that's got that middle privilege, your permissions, your individual permissions allow you to read data and decrypt using a key that allows you to read this middle level. Whereas I don't, and I can't see it. So you can kind of achieve the same sort of isolation without using the network. I've heard people say the perimeter is now identity, not the network. And I guess that's what they mean, is like using encryption keys and access roles to kind of really create that same kind of construct.
Yeah, that makes sense. Yeah.
Just following on from that in terms of security then, Michael. So if you're a big data admin, and so you're only a big data admin within your specific zone, I presume you'd want to create multiple hierarchies of IAM roles to actually achieve the same sort of effect, wouldn't you?
You could, but you know what? You could tie yourself up in knots really quickly. And that's usually what happens. This is what, going back to the question with the security team, you sit down with the whiteboard with them, and the next thing you know, you've got 45 different roles of combinations with 56 different encryption keys, and that's it. You're done. That's the danger.
Yeah, but out of curiosity, isn't a big data admin given access to the entire project by default?
Yeah, well, yeah, but what you can do, you can provide more granular permission. So access to the services and access to the data you can separate. So let's say you might be, and a common one actually you see there is this, let's say a world where, let's say we're in a big enterprise and you've got lots of different Google Cloud projects, all isolated with different, data sets in them, different workloads, different keys. But you might have a security kind of role within your organization, and they can access any project, anywhere, any system, but they might not have permission to actually look at the data. It's the same kind of thing. So they've got the keys to the hallways, but they can't open all the lockers, I guess, inside.
Right. Okay.
Yeah.
And as one quick scenario question, which I was curious about. So you're a global company. You've got data across the globe. You're replicating data across each data center, but you want each data center's data to be unique to that location only.
So like ring fenced and yeah. So all the stuff I showed you today, you can do that with. The only things at the moment that aren't regionalized are AutoML, which is a real shame because it's wonderful. AutoML Vision, AutoML tables. That's all processing is not, you can't ring fence that in Australia at the moment, but all of their AI platform stuff, everything, Bigquery, BigqueryML, Google Cloud Storage, all the data, everything else, you can completely 100%. But Google did it in reverse. So when I worked in my last place, everything was built regional. And then, but there were some big companies, customers that needed global services. So they're like, wow, okay, we need to go from regional to global. Google built everything global and then had to regionalize it. So they're like, great, we've got PubSub, which is global scale, 500 million records a second. And they're like, that's great, but we need it regionalized for Australia. And they're like, okay. So they've kind of had to do from the other way, if that makes sense.
Yeah, it does. But wouldn't that kind of limit Google in terms of the security audits and stuff like that they need to clear?
Not at all. So if you look on go cloud.google.com/security, all of those independent analysts and security reports, you won't see anything that Azure and AWS have that we don't, and you will see some things that we have that they don't have. Yeah, so everything is, independently audited, and Google can't use your data for mining it for marketing, despite what one of my former colleagues at Amazon once told me.
Well, But there
it's
is
all
that
independently
perception.
verified. It's true. And you know what? When I'm talking to new customers, the first thing usually talk about, just to get it out of the way, is you show them all of those independent accreditations. You know, like IRAP in Australia, APRA, all the global accreditations as well, and just put that at rest, because for some reason there has been that perception.
That is good to know. I think otherwise it will be added another challenge with these the ongoing debate and the fight between Google and the media and the ACCC. So I think thank you so much again for coming this presentation and all the great questions from Sharaf and Chris. I hope everyone enjoy, and I look forward to see you coming back to present again sometime again in the future.
Yeah, definitely.
I got an anchor for Google, so we will see some topics. Michael, thanks for doing it again. And let me know, if you want to organize another topic or another speaker from Google. I mean, there are some topics where we can do a lot of deep dive, and we're also happy to, host your customers if they want to share any customer stories. That'll be a good industry talk as well.
And if you guys haven't followed Michael, make sure you go and follow him on LinkedIn, his LinkedIn profile, as well as the presentation today will be shared by the email or the message from the meetup.com later. So I think that's it. Thank you so much.
Thanks, guys.
Thanks, everyone.
Thanks, guys.
Enjoyed it. Thanks.
Bye.
See you, Michael.
Bye.